is IoT data collector? Basically, it is a platform which allows connected devices easily and securely interact with another application systems or another devices. Our platform is a distributed microservices-based application, and it is implemented in Java. And this platform is using or utilizing two main frameworks. One is the Hazelcast for building the distributed grid-based distributed computations and applications, and the Vertex, which is again microservices based framework, and all our services, all the services provided by the collector are using or are built on top of these two frameworks. From the architecture perspective, IoT data collector consists of three modules. We are recognizing audit, receiver, and sender. And now I will just very briefly go through all of these modules so you will understand what these modules do. Audit is providing the auditing services, and providing state use of receivers and sensors. So it is basically managing all the infrastructure, including the licensing services, including the management services like restarting of the modules, redeploying the verticals, and getting, for example, the log files from the modules. All this is done by the audit, so it is like a single point of control. So if you want to configure, or if you want to handle a receiver or sender module, you are always going through the audit. As I mentioned, it recognizes and cooperates with all the receivers and senders which are deployed on the same local machine or remote machines. Of course, you can operate BellaDati IoT data collector on one machine, but usually we are operating it as a cluster of the services, and these modules are then managing the cluster as well. What it does, it automatically recognizes other modules that are running on the same machine or on different server. It is using either multicast approach, or eventually you can, of course, namely set the list of the machines which are available to the audit, and on these machines all the services are automatically recognized by the audit module. Then two modules, receiver and sender, which are responsible for communicating with the outer world. So the receiver is the first point of contact, let's say, for the IoT devices, and it receives data from the IoT devices, or eventually it subscribes to the data published by the external devices. It can operate in various modes. To the most popular modes belongs the MQTT server. In this case, the receiver is running as MQTT server, which allows devices to either subscribe to the topics published by this server or to publish messages to this server. Then the operation mode subscribed is just from the other side, so the module, the receiver, is able to subscribe to the existing MQTT broker and receive data from it. Then to very simple one, HTTP post consumer, so it accepts the data from the HTTP post request. Of course, it could be put request, it could be get request. It is not just stick on the post request, but this is the most common one. Then the UDP server, the module is able to accept the UDP datagrams. Of course, there could be much more, because the server itself can respond with the datagram that it was received and successfully processed. So there is always much more. To have just very brief list of the available modes. The last here, but not least, is the custom implementation. This is very important to know, that each receiver can be extended according to some specific needs, which are depending on specific platform, on specific hardware requirement or whatsoever. So you can take the developer's package and you can implement your own module. Of course, this will be the topic when we will talk about the API and SDK, so we will come to this later as well. The last module is the sender. It reads data from the receiver and conditionally executes automated actions. What can be as an automated action? We have direct integration with BellaDati, so it is possible to send the data to the BellaDati. Then it is possible to send the data to the third-party system using HTTP protocol. It could be OAuth based, it could be REST API, it could be whatsoever which is running on the HTTP protocol, of course, including the SSL, TLS support. You can send the email, you can send a text message, which we have, for example, with the eCall service. You can initiate whatsoever third-party action. Of course, you can save the data, you can publish the MQTT message to the MQTT broker, and what's very important, you can provide a custom action implementation. So again, you have to make your hands dirty, or you can make your hands dirty, and you can extend the current implementation with your own custom implementation and deploy it into the infrastructure. So this is the illustration how it works. On the left side we have the devices which are serving as an input to the collector, and we have a receiver here which is exposing the endpoints, which could be of type HTTP, MQTT, UDP, web services, or whatsoever. These messages are then processed by the message rules processor. These message rules can be defined according to the structure. These rules can be as well stick on the values or some maybe some IDs of the devices. Of course, the receiver is automatically handling the authentication, which can be set up in the way that it will be like basic authentication, digest authentication, certificate-based authentication. In this case, you have to, of course, propagate the certificates to the client devices, which will then prove their identity using this certificate to the receiver. And once this is done, once the message is processed, the message is stored in the distributed data storage, grid data storage, which is available to all modules. And then the sender is just taking this data, is just touching this data, which are received by the receiver, and the action rules are applied. Action rules is a very simple, like a decision tree, whether to execute particular action or not. And this action could be, as I mentioned, MQTT publish. So, for example, the receiver can receive the HTTP post request, but the sender can act as a MQTT publish, so it can, based on the action rules, can execute the automated action to the output. So this is like a very simple illustration. Andre in his demo will show you a very simple example, which will be based on receiving the HTTP post request and executing automated action, which will be of type MQTT publish. So to the requirements. Let me just show you the browser in here. Can you see the web browser?
Yes.
All right. So as I mentioned, it is a Java application. So you need to have a Java runtime environment, which is basically distributed together with the installer. So you can download the installer and install it on your machine without installing any other software. But to the minimal configuration, you can start pretty low. So you can have a machine with a CPU, 2 GHz, 1 GB of the memory, 1 GB disk space, and the network 3G, which is quite slow, but it's sufficient. And then you can, of course, move to the medium load configuration, which is it is like a recommended configuration, recommended setup. But of course, usually we are recommending the specific configuration according to specific customer needs. Of course, this is like a most common setup. Then the medium mode configuration, which operates in the distribute mode. So we have one machine for the auditing purposes, for the audit module, and then additional servers for receivers and senders. And the same principle applies to the high load configuration. It is distributed. It is able to solve up to millions of sensors, which are sending up to 60 requests every minute. So it's pretty much. And in this case, we are recommending such ratio which consists of modules for receivers and senders divided by the sensors count. So regarding the software, of course, we can operate on Microsoft platform, various Linux distributions, Mac OS, Solaris, whatsoever. If you want to run it manually, it means not through the installer, you can consider either Oracle Java or IBM Java distributions. So this was to the requirements of the IoT data collector, and now a little bit again back to the collector function itself. So just to be sure we are on the same page, we have again receiver which is responsible for receiving the data, including the authentication, including the evaluation of the message, including checking whether the message conforms with the particular rules defined by the collector. So we see, for example, here we have data from the crash transmitted to the collector. This message is then evaluated, and based on the severity of the crash, we can decide whether it was hard crash or light crash. So we are sending their numbers from 1 to 4. If it is like a hard crash, it is numbered with the number 4. Light crash 1. If it is a hard crash, we are then taking the action, which is sending the SMS alert and propagating the information to the eco console, which is running in BellaDati. Then the light crash, it is just forwarding the message to the pay habit drive statistic. So we can act based on the data received from the device. Regarding the security, I want to highlight again, IoT data collector is able to operate with the basic authentication or the OAuth authentication, eventually with the client SSL certificates, which are then of course provided by the IoT data collector. So in this case, we have here a light data sensor which is transmitting some data level of the light or luminosity whatsoever. It's of course authenticated, and the collector is processed the message, and again, using the standard secured protocols, it is providing the output to the gateways or to the MQTT brokers or whatsoever. So the question is how to operate the collector. You can operate it manually, completely manually from the command line. So you will just install it and change everything inside the configuration files, which is sometimes complicated. But if you want to do some crazy customization, it's the only way how to do that. But for the normal standard operation, you can use the IoT console. And the IoT console is a web application dedicated to manage the underlying IoT data collector modules. It allows you to have it like a single point of control, so you don't need to configure each particular module separately. You can do everything inside the IoT console. And it is integrated with BellaDati. It means you don't need to think about data sets, you don't need to think about applications or attribute codes, indicator codes. Everything is already available in the IoT console. So you will just, in case you are sending the data as automated action to BellaDati, you can just pick up the right data set and send it to the IoT console, IoT collector, so it will be configured automatically. The same applies to the mapping. The same applies to the machine learning, for example. It's very important. We will talk about this later during this session. So you can process the data, you can trigger the pipelines which are in the machine learning studio. You can like change the models which are defined in the machine learning studio just based on the data change which is coming from the IoT collector. And the last slide here regarding the collector, then we will follow up with the demo. The slide is regarding device onboarding. Device onboarding, in our understanding, is a process by which a new IoT device, it could be sensor, it could be mobile phone, it could be XDK. So it's a process by which this particular device gains the access to BellaDati IoT data collector, or allows the collector to get the data from this device. So it basically defines the authentication. I mentioned it many times. The basic digest, SSL certificates, or non-authenticated devices can be as well used. Of course, in this case, there is a huge risk that somebody else will be able to read the data or send the data. It's just for the sandbox or for demo purposes. And device onboarding consists of defining the message rules and the actions. So all this can be done manually, as I mentioned, on the server or through the IoT console.